start with a presentation. Oops, so that's the wrong one. Sorry. So I think now you see it. Yeah. What we want to tell you about this about today is about harmful algae blooms, threat in drinking water works, and BBE products application in this field. Detlef Lohse is my colleague, and Tobias, myself will make this presentation. Also, please sign. I'm already told Babak that you have questions. Please write it in the chat, and then we will follow up later on with these questions. The agenda, we start with reviewing the algae bloom and its threats. Then we have a little bit aspect of algae treatment methods, and the main question we have in cyanobacteria, and that's the main problem in waterworks, and about online measurement and at different treatment steps, and question and open discussion later on. And also please open discussion also if you have some other topics, not only questions, please let us know about what you are doing there.
Yeah, good morning to all of you from my side. I will start here, tell you something about algae blooms, and we have to distinguish algae blooms and so-called harmful algae blooms. So that means algae blooms can happen every year in the springtime when we have bright sunlight coming up and we have the growth of algae. But beside of this, we have also harmful algae blooms because they can produce toxins. So these small, microscopic, small organisms, they produce inside metabolites, which are toxic to human, to cattle, to everyone, also to some water organisms. So when they bloom, this means that they become very dense. You can see this here on the left side. It was in late winter time. It's strange, but it tends to become more and more. And then this displays other algae. And if this grows too much, then they will die. They consume all the nutrients and they will die. And then consume also the oxygen, and it becomes dead zones. And this is a reason why this water is threatened by this growth of harmful algae. And with this also we have the release of taste and odor compounds, which they also produce, and this smells and tastes not horrible. So what you can see here is a typical blue-green algae. This is something what we call close to the bacteria, but they are photosynthetic organisms. The microcystis, we come back later to this, but they are very common here in Europe, but all over the world. So in the next slide, I can tell you something about the upcoming blooms. And what we see here is Lake Erie in US America. It is the largest freshwater reservoir. And on the left side, this picture is from 2014. You can see there is an upcoming bloom. This is the green color you can see it from satellite. And you can see that these blooms are spreading much more and more. And you will find them mainly in fresh water, but you can see also that they come up in marine water. We have other algae which are very common in marine water, but sometimes and more you find them also in marine waters, these cyanobacteria. So for example, at the coast of Florida, we have now measuring stations where they survey the upcoming cyanobacteria blooms. So in the next slide, I can tell you two other places. What you see here is first it is India. It's the frequency of occurrences of algae blooms. And what you can see, there is an upcoming number of algae blooms with the years. That is from India. The other part is again US America. This is a forecast. It was for 2022. It's not complete, but what you can see also rising frequency of blooms in this freshwater. And of course, these freshwater reservoirs, they serve for drinking water production, as around this lake area, they have numbers of waterworks located. So that's it for this. And we now look for the different algae blooms that we experience. I made this estimation about algae blooms from different literatures. And what you can see that algae blooms, they come up from cyanobacteria, that is the blue color. We have these dinoflagellates as another form of microalgae, which are in the marine zones. And we have the diatoms, which are a typical spring phytoplankton. Diatoms are rarely toxic, but the cyanobacteria and the diatoms, they can produce those harmful toxins. And as these are really toxins, the World Health Organization, they made an estimation how much of these algae are allowed to serve or to use this water as drinking water, or let's say for recreational purposes as bathing waters. But here we focus on drinking water, and what you can see, they made an estimation of the chlorophyll content, because the chlorophyll content is much more easier to check than the content of biotoxins. But usually, as we know, biotoxins, they accompany the upcoming occurrence of algae. The cyanobacteria chlorophyll content could be a good way to check if there is a threat for the drinking water. And can you please switch up? Can you please switch off your microphone if you are not speaking? And so the World Health Organization, they made a guideline how much of these toxins could be accepted inside of the drinking water. So this is only a guideline, and this is not fixed. But what we know is that the different countries, they have different thresholds. So that is what you can see. But here we focus on something which we can measure directly. So we look for the chlorophyll content, which may serve as an equivalent for the biotoxin. Okay. And in the next slide, you may ask what might be the reason for these upcoming threats by cyanobacteria, or we call it also the blue-green algae. Yeah, that the cyanobacteria is the same name for the blue-greens, and we have here the reason quite clear. The high number or amounts of fertilizers that are used today, they use nitrogen and phosphate. And phosphate is very good for the growth of cyanobacteria. And as the fertilizers are washed out from the fields into the water, come into the lakes and the rivers, and allows the blue-green algae to proliferate. Then we have another important factor. This is the bright sunlight. When the sun comes up in summertime, it gets warmer. Then they like it very much at the surface, to stay at the surface and to use this light for photosynthesis and for their growth. And also the increased temperature may be also caused by the global warming change, will help them to grow much better. So that are some reasons why they can be so positive in their growth. And we have, of course, some consequences, and I have a short list here, what they can do, harmful things. One thing which is really important thing, that is the most noted disease, is irreversible hepatotoxicity. That means the liver is affected, and it is known that they have also tumor promoting, can follow up for promoting reactions. Some literature brings out correlation between the biotoxin microcystin from this algae I showed in the beginning and primary liver cancer. Other literature shows connection to degenerative nerve diseases like Alzheimer, Parkinson's. This comes from China. But what we know is also direct effects. For example, it works as a skin irritant, this biotoxin, for example, from the aerosols, because they are small cells and they can be in the atmosphere and come to your skin and make harmful effects. And of course, last of thing, which is not toxic, but it is not accepted, is an unacceptable taste and musty odor inside of the water. So that means the customers of the waterworks will not accept it. Waterworks do a lot of things against this, for example, chlorination, but the very best way is to circumvent these effects. All right.
That is a little bit a picture of a lake. Yeah? And what happens in these lakes, you have from the rivers, already Detlef says, you get nutrients, phosphate and nitrate in the water, oxygen from the surface, yeah? And dust from the surface, and then you get also what's often happening, upwelling nutrients and oxygen if the wind and the waves covers the bottom of the lake, and then you get nutrients back from the bottom of the sea. And what's going in the food chain, the phytoplankton is the beginning, then the zooplankton eat them, and the fish and so on. And so the phytoplankton is a main factor in this food chain for all organisms. About the monitoring and detection of the biomass, we have to, there are different methods. One is ACP, microscope counting, a little sketch here, HPLC, it's a high pressure liquid chromatography, and the flow cam, it's an automatic microscope. Yeah. Most of them are laboratory instruments or automated laboratory instruments, but you need some manpower. The flow cam has very little tubes and so on and so on. But algae, as I saw, also a major problem in open water, and you can really, with fluorescence is the easiest way to measure this in situ and in vivo instruments. You see here our products, lab analyzer, algae torch, algae online analyzer, fluoroprobe, and then the fluorescence is related to the phytoplankton biomass, more or less. Yeah? But you can get a good relation between them, and the best is fast and reproducible. Some examples, you have the water treatment plant in Buckingham. We are here in North America. There's a little lake, clear lake here on this north of San Francisco. In this clear lake, there's a little half island, and there's a Buckingham Park Water District. This is an area where the measurement and where I made a lot of measurements there. There's a water intake pipes, and after them they make an oxidation with 12.5 sodium hydrochloride chloride. They have to pressure filter, sand and anthracite, run parallel. All of this sand filter has to be backflashed once every half a year, I think. It depends on the algae bloom. Then they have a coagulant to sediment in the tank, and they have a monitoring with the BBE fugula at different treatment steps. Yeah? And we work with them together already since 2019. Here you see some beta version of a satellite determination of cyanobacteria. And you see here over the year, the wind is going westerly, then all the algae goes to the western side, eastern side of the lake. And sometimes it's easterly, but you only see the first 5 to 10 centimeters in the water bottom, depending on the turbidity. And you also see only the surface. Yeah? And that is the main situation that they also measure with our instrument. We have a case study with over 2 years that is May in 2019 till more or less now. We have got every week a measurement about in this water body. And I want to thank Will Ray from Buckingham Water Test. He makes a weekly data set with our instrument, and we discussed about this data a long time. If you see only this area here, then I can see the different algae we can determine there. We have the green algae, we have the diatoms, we have the blue-green algae, type of cyanobacteria, Plantotrix rubescens, another type of cyanobacteria, unbound phycocyanin, and yellow substances that are the parameters we measure beside the total chlorophyll. If you see that over the years again, you see an increase over the 2.5 years. I spoke with this group at this Clear Lake area, and it is really significant that they have really algae blooms in this area from 2019 from 30 now to 150 is a big rise over the years, and that's very interesting. Then what you also see that diatom and green algae bloom in spring. That is typical. Also, Detlef told already a little bit, and you have this blue-green algae more in autumn. But if you are more focused on the cyanobacteria, you have here the blue-green algae, the Plantotrix rubescens, and the unbound phycocyanin. You see the same tendency. It's a very high increase of the cyanobacteria from here 9 up to 40. That is really 4 times bigger. What's going on there? And you have that is a very also during the period in between, you have cyanobacteria, and in the past there was all the time in the winter time no cyanobacteria at all. You see the autumn cyanobacteria dominated. I already told you in the other picture. And you see also that the duration of the cyanoblood gets longer and longer. That is not really that it's very small situation, a short situation that gets longer and longer.
Yeah. So, but people people know about these threats, and of course there are several methods to deal with these problems that they have inside of the water. And one way to deal with is that you could use chemical treatment inside of the water. That means what Toby already mentioned, you can use hypochlorite, you can also use other compounds like copper sulfate, amounts with a high oxygen content, for example, to oxidize these. And of course, these are somewise very helpful, but they have also disadvantages. And one of these disadvantages, so we will come on later back to this, is what I show here in the picture or in the scheme, is if you use these chemicals, for example, they can penetrate the cells, they come into the mucilage, and then they can lead to cell lysis. And with the cell lysis, you make the problem potentially more severe, which means that with the cell lysis, you can also release all the other contents of the cell, including the biotoxins. So that means that even if you destroy the cells, you cannot omit the effect of biotoxins inside of the water. Of course, there are trials to oxidize also these biotoxins, but it is not always very helpful. Another point is if you use this treatment, let's say also together with ultrasound, which is another point to deal with, it means that you can destroy them for a while, but is it really effective over the time? Yeah. And if you have small ponds, it may be effective. If you have large water bodies, it's very difficult to use it. Imagine how much of the copper sulfate or other chemical you need to use it in a large water body. Another one, which is also used here in Germany, is a water circulation. The idea behind is that if the microalgae and the cyanobacteria are not so close to the surface, they cannot harvest the sunlight. But it's also a way that's helpful for a certain while, and it will come back. And so what we know here, even if you ask a company to use some of these methods, then of course they can help for a short time, but usually this comes back later on. Skimming is another one, you know, or perhaps you remember that during Olympic Games in 2008 in Beijing, they used this way with lorries. They brought away all these algae from the surface, but it's very costly and is also difficult. And the other one, which is often used, for example, here also in Germany, to use a removal of the fertilizer to bind, for example, the phosphate. It can help, but you have to know that if you have, let's say, phosphate in the sediment, it will come back later on. So these are methods that are widely used, but you can really say it is not very easy to deal with this, because if you cannot remove the problem, that means that you have a lower amount of phosphate and nitrate, then you cannot circumvent it. But the best way is to check all the time if you have the comeback of the cyanobacteria after your treatment method. Right.
I will show you some example also from this Buckingham Park measurement. You saw on this yearly graphs only the raw water, but they measure the different treatment steps in this with this instrument. And you see here on the left-hand side the raw water in Buckingham, and then he measures the oxidated with 12.5 sodium hypochlorite. They treat the water, and they see that the cyanobacteria go up, and also the unbound phycocyanin. That means that they oxidate the cyanocells and release the unbound phycocyanin. And that could be measured with this Phyco lab analyzer, and you see that it's going up. Later on, it is also treated totally, but the toxins could be free. There was only sometimes they make more toxin measurements, and from Coca-Cola, and they saw a high value in Buckingham of mucocystine in this water body. So that is also important that you see. Yeah? Now another topic, filtering. I've been in Peru with install a fish toximeter, but here they also have a bento torch, and it was very interesting application they made. There are these drinking water basins here, you see, and they measure the bento torch on the sand filters and see the value of the bento algae in the water, and then they know if they have to remove the sand. If they measure in the sand and it gets too high, the bentic algae on the sand, then they have to remove the sand, and they measure also on the walls if they have to clean it more proper or not. And that is a good interesting application in this with this instrument. Here some results. You see here the cyanobacteria, green algae, and diatoms, and total cell counts. And you see that on some places there are a lot of cyanobacteria and diatoms, and some areas are not that much. And that is very interesting application.
Yeah. May I also mention something that is often overseen? People think that they only have to look for the algae content in the open waters, but they oversee that a lot of algae, microphytoplankton, and cyanobacteria, they grow on sediments, and they grow clear the coast or in very shallow waters. And this is a high amount of biomass, which is quite often overseen. When people take a sample from the open water, bring it to the water, it is not the reality. But here in Peru, you can see that they use it also to determine the algae contents on surfaces. And this is a high amount of photosynthesis that takes place. And it is well known that the cyanobacteria on these sediments, they can also produce these biotoxins. All right. Yeah. So what we know and what we are hear from the people from the waterworks, what these biotoxins, this cyanobacteria, what does it mean for them? Why this is a threat? Well, it could pass filter elements, for example, sand filters. Yeah, these biotoxins, they are not very good soluble in water, but in low amounts, here in the ppb and the ppt range, they are soluble and they can come in and they can cause accidents and diseases. So you cannot see them directly. They are invisible and they are tasteless and odorless. You have to bring them to a laboratory to determine the amount directly. They show a high toxicity and both acute and chronic effects. I just want to mention that if your dog drinks something, some of these waters, the dog can die in a few hours. Yeah, the detection needs laboratory equipment. If you want to determine it directly, that means that you have mass spectroscopy, for example, to use this. It can only be done in a laboratory. Others use microscopy, but this also has to be used in a laboratory or with a field microscope. It's very laborious. And therefore, no online biotoxin monitoring is available at now. And we think that it will take a lot of time. People try to find out something. And of course, there are countermeasurements, but these are really costly. And so therefore, it's a good way if we have an idea what is inside in the water to monitor it directly and to get an indication what could be the threats of cyanobacteria in this water. All right, and we have here an example, a typical example. It's more the problem, let's say, for the reputation than the problem for the health. In 2014, water from this Erie Lake, you see here the water tower here inside of the lake. They took up some water and brought it to the waterworks, and it entered the drinking water system. So the biotoxins came into the water supply and into the households. Unfortunately, the people know about this fact, but they did not use the opportunity to tell them. So it took 2 days until it was recognized that biotoxin entered the water supply. Of course, immediately all bottled water was sold out, but I think there were two problems. One is with the press release that people lost confidence into the waterworks, and the other one, it is let's say the risk, the health risk. This water can enter this water supply system and could affect people's health. Right. Yeah, some pictures to show what these organisms are and what these toxins are. It's just a short overview. We have here this formula of the microcystin. It's most common. This is the hepatotoxic compound, which I showed you in the beginning. We have this group of microcystins, more than 200 of different configurations of these molecules. And the typical way is the microcystis aeruginosa, shown on the right side, toxic. And we have other one here. We have on the bottom, we have oscillatoria or planktotrix. And we have on the right side, we got that's right. This is Anabena. They produce a very, very harmful toxin that's called also very fast death factor. It is an alkaloid, it's really toxic. So if it's inside the water, it has clearly to be avoided. So therefore, there should be something done to detect these very early if it is in your water. All right.
I want to tell you something about the waterworks in Germany. We are here in the bottom Kiel. There's Babak, Detlef, and myself on our company located. But the situation, the example is here in North Rhine-Westphalia. There's a big reservoir, a drinking water reservoir, operated from the Stadtwerke Solingen. And that is very interesting lake. And there was also the situation that Detlef told already, that there was is also a recreation area, and there was a person with a dog, and the dog died in a few hours, and he asked the waterworks, "What's going on with your water? Oh, my dog was dying." Yeah? And then he saw that this dog died, that this was plantotrix rubescens. They make laboratory analysis about that, and this is a tower where the lake, where the waterworks goes in, and it's a massive dam, and that is very interesting. Yeah, interesting area. They are also very nice, but they have this problem with this plantotrix rubescens. Then they okay, we have to monitor this plantotrix rubescens, and they bought an algae online analyzer at the waterworks in Gülenda, and here you see this algae online analyzer, pH and turbidity is here on this side. It's an online analysis of this water body. You see the values here in this graph here inside. It's 24/7 online detection with alarm levels of all algae classes. You can just say if the cyanobacteria are getting too big, yes, you should make an alarm. And they have also a valve system here. It's here's a little pump, and then they have a valve system to measure different treatment steps. They may measure, for example, raw water and ultrafiltrated water to see if the filters are running good, or if something happens. If you see the algae online versus cell counts, you see here the BBE plantotrix rubescens measurement over the time, and they make also a laboratory test, and you see that there's a good correspondence in that. But you also see there's a big problems, difficult to count this filamentous algae, yeah? And that's the reason the algae online analyzer has a big differences during the measurements, because if there's a big filamentous going through, or a smaller one, so that is the reason it is not really a strict line. The waterworks is often in the depths. Yeah, see the water intake often not on the surface, but it is in the depths, and the algae composition is strongly depth dependent. So if you only see the surface via satellites or so on, you do not know really what is going on in your intake area. That's the reason they use also a fluoroprobes for depth profiling. If you make a fixed installation, you need a wiper. You can also add on and dissolved oxygen and multi-parameter dissolved conductivity and pH available with this fluoroprobe, also a cuvette extraction. So you can really measure laboratory samples in the laboratory, or you make depth profiling or long-time installation, and you get also the beside parameter depth dependence. If you see the depth distribution of plantotrix rubescens and total algae, you see here over 2 months measurement of this fluoroprobe, and you see here the temperature dependence, and you see here the plantotrix rubescens are, and the total chlorophyll are in the depth of 20 meters, and you see there during the year the depth dependence changes, and at the end of the year, or if the bloom is collapsed, and you have nearly no plantotrix rubescens at all anymore. That's more or less what we want to tell. Just some example of our fluorometers. You have this lab analyzer, and you have this algae guard. It's a flow-through instrument with a pump, and algae online analyzer with a more functionality to measure also different algae and have a lot of different outputs available. The fluoroprobe, the algae torch, and we have this oxygen sensor and this dissolved oxygen conductivity and pH with this instrument here.
Toby,
Yep.
May I come back to the slide? I think it's interesting to mention here, you told us something about these water intake from the waterworks in North Rhine-Westphalia. At the extraction points, these towers, they have different extraction points, different depths, and they measure this all the time with an online analyzer. So they, from the extraction point, they get the information, but this is at a fixed point. So when they want to go out to use or to determine the cyanobacteria in other areas, they need a mobile instrument, and this is used with a fluoroprobe. So they have both instruments, one at a fixed point where they measure inside of the measuring station, and the other one, they can go out with a boat along the distance of this reservoir and see how this changes with the distance from the extraction points in the reservoir and also with the depth. So they get both information that are needed to check the quality of the water in the reservoir.
Just to add it also, they also bought a lab analyzer. That was really the biggest luck we had, that they really bought all of 3 instruments, because they have also some smaller lakes around, and they take samples regularly and measure them with a lab analyzer. Okay, thank you very much. That's the Bay of Germany, Netherlands here, Netherlands on the left-hand side, and so on, Denmark on the upper area, and that's the Elbe River. So that's from our side. Please, questions, your experience, remarks, please feel free to have an open discussion and start with some comments and questions. Maybe, Babak, you have already selected
Collected.
Some.
Yeah, just one question for this slide before this Perian bento torch.
I go 1 second. I go back to the before the bento torch. That was
this was
this one.
This one. So the question is that what is the I mean, this units of this horizontal axis.
This is a microgram per liter.
No, but the horizontal, I mean.
That is just hours. They put a raw water sample and measure every 5 minutes or every.
It's 5 hours, maybe, or
no, that's minutes. 5 minutes.
5 minutes. Okay.
They just take one sample and measure 5 times this instrument. It took 1 minute because they also measure the activity of the algae. I haven't displayed. They measure the raw water sample and the activity, and that's also every 5 minutes the oxidated.
So they take sample manually and they bring it to the phycola, yeah.
Yes, it's not an online instrument. It is, I think.
And the question, actually, this question is for myself. Why cyanobacteria increase suddenly?
Because the cyanobacteria. I go back.
Where's the slide? Yeah, here.
Yeah,
so you have a certain amount of cyanobacteria, but after a few minutes, it increases cyanobacteria itself.
It is the unbound phycocyanin. You measure also if the cell lysis happens. Yeah. And also
but the blue line is cyanobacteria.
And the chlorophyll A also gets out of the cell. And so it's a mixture of chlorophyll A, because it is not really, the fingerprint works here more or less okay, but if the cell lyses, also the phycoerythrin and the phycocyanin and the chlorophyll A releases the cell, and that's the reason it goes up a little bit.
If you have not, when cell lysis, the pigments of the chlorophyll A for cyanobacteria also increase a lot.
Yes, and the cell lysis also happens if the electron transfer through the cell is also destroyed. So the effect gets bigger.
Understand. And later, by the time this oxidation happens and this, this infection, this hypochlorite, sodium hypochlorite, absorb this bond with this materials.
Yeah, this destroys everything then later on.
But I think it's more an artifact here. When you see that it comes up from, let's say, 4.5 up to 4.9, yeah, and you see also this with the yellow substances in the relative units. I don't know if it's the scale on the right side, but it goes also as a little jump, yeah. I think it seems to be a little bit artificial. I don't think that is a real effect.
Okay.
But what you can see that is the decrease from almost 5 at the end to 2 with the cyanobacteria chlorophyll. Yeah. And what you can also see that the unbound phycocyanin dramatically drops.
Yeah, but also it is mentioned here that macrocystin analysis show high values at Buckingham macrocystin. This is my question, actually. What is this? What is the relation to macrocystin here? We mentioned we have a correlation between macrocystin and cyanobacteria. This is our assumption, yeah.
Yes. But they made also some laboratory tests.
Okay.
It's really laboratory tests to see what toxins are inside. Yeah, and they measured. We want to have it every day, this analysis, to verify what we are measuring, but that is too expensive. So sometimes they make some macrocystin analysis, but that is really not, it's very time consumption, and it's not only working for us. This Carola Kennedy is working for the whole Californian water works.
But if you have some of these values from the macrocystin, it would be nice if you next time add this to this diagram.
It would be perfect, but I have to ask.
Okay, understand. So there was another question also. What is the minimum time interval that we can measure with our units?
The algae online analyzer can measure, I would say, every 5 seconds would be a good opportunity, but you get a large amount of water, of values. Yeah, we can also measure, I think also 1 second is possible, yeah, but less is not possible. I think that makes no sense. And if you measure activity, it takes some time because of the light and laser light and so on. It took more time.
Yeah, well, many people who use online analyzers, they perform a measurement once per hour. Of course, you can reduce the time, but this is often sufficient to have an overview about the dynamics of the water quality.
Okay, and like always, the same question: what is the accuracy of measurements?
It's 0.01 microgram per liter. But if you make really with this low concentration, the fingerprint situation, it is not that perfect at all anymore, because but the minimum is 0.01 microgram per liter.
This is for total chlorophyll A.
Total chlorophyll A.
Yes. Okay. Yeah, and the last question, actually, as far as I copied, it's what is the maximum depths we can measure with our handheld probes?
It's
in the dam reservoir, for example.
And with the handheld probes, with the algae online, with the algae torch, you can measure 10 meters with a standard version. But there's also a special version that has a more better plug for sealing. Then you can go down to 100 meters.
Okay. And for AOA, it's a matter of the sampling. This is my own question. Yeah.
Huh?
For AOA.
Well, with the AOA, yeah, for AOA, it's a very special case. The AOA uses a peristaltic pump, which pumps the water inside of the instrument. From theoretical value, it can be 10 meters, yeah, but you have to imagine there is a delay between the intake of the sample until it enters the instrument. So that means usually I think it should be not much more than 2-3 meters.
Yeah, okay. So in the chat area, the question finished from, but if anybody has a question, you can open your microphone and you can ask questions from our speakers.
please feel free. And also, if you have some experience with instruments, please let us know. And just we have some time, I think a quarter of an hour, and please feel free to ask some more questions.
No question.
Then everything is clear.
No. Yes, there is one.
Yeah.
I would like to ask two questions. One is about AOP oxidation test to treat algae, and the second about your offer on intercalibration circuits. We would like to know more about this test and with frequency during the year when we buy your product.
You mean that how often we need calibration for our traps? Is it correct? We understand?
Yeah.
Okay.
The first question I can tell you about the oxidation. Yes, we made some tests with this Buckingham Park situation, and we saw they have optimized their calibration. Sorry, I got where it is. Sorry. Here is it. Yeah, here is it. They made some tests, and the best value they got was 12.5% sodium hydrochloride. With this, they test our instrument, what's going on, and they use the instrument all over the places if there are some unbound phycocyanin. But they made some tests, 7, 12, 15, 25, 80, and the best oxidation value they had was 12.5%. Sodium hypochlorite. But you have to also to look to your regulation. In US, you can also use chlorine, yeah, to implement in the water.
In our laboratory, we performed some experiments about the release of these internal compounds like the phycocyanin, but also the biotoxin. So there is a publication available about our laboratory tests. So if you are interested, we will be happy to send it to you. Are you interested?
Yes,
Yeah.
we can speak. I do my mail and my registration.
Yeah. Okay. Then please send us an email on our website, and we send back the publication that you can see how this was done. We used, interestingly, we used potassium permanganate for the oxidation process.
Yeah.
Yeah. So this is another way to oxidize the cyanobacteria cells.
Mm-hmm.
And the calibration, we recommend to calibrate the instrument every 2 years, but there are totally different situations. Some of them say we don't want to calibrate it, it works perfect, yeah? And others say, okay, we have it by law to make this 2 years calibration, and some of them make 4 years and so on. But it is also, all the calibration is in our laboratory, because we use real algae for calibration. That's also the different to other instrument. We really use real algae to calibrate this instrument, that you get really different algae groups measured.
Okay, another question, because a colleague is not present in this webinar, if you can send your PowerPoint, and if you do a video in YouTube, in some channel.
I have record this presentation, and you can get the record from us, and then your colleague can listen to it.
Okay.
Also, I can add something. In YouTube, we have a channel, and you are mostly welcome to visit our channel. And there's interesting videos. I can say that every month we have new videos about our products and different users. So I'm trying to share it to our channel here also here.
Okay. Also, Dottoressa Murtas, can see the video now because is busy. Okay.
Thank you.
We send you a link about that, and then you can use it. Just send us an email and remind us that what you want. Well, perfect. Please, another question. Maybe someone has some questions. If you have later on questions or remarks, please send us an email or to the distributor the email, and they will forward it to us, and then you will surely get the information later on. And I hope, I think, if there's no questions, please, I hope it was successful for you or informative for you. And yes, and I wish you a nice working day, working week, and hopefully every one of us stays healthy and this stupid war will be finished as fast as possible, that we get a safer situation worldwide again.
Thank you.
Okay.
Thank you very much.
Thank you.
So
Goodbye.
Goodbye.
Bye-bye.
Bye-bye.
Thanks. Bye.
Bye, Gianmarco.
Bye to
Marco.
you all.
Yeah, thank
Bye
you.
bye.
So, how are you?